All right, welcome to chapter 6, which is the secure network configuration. Let me tell you ahead of time that this is going to be a long video because it involves very important concepts. This is a great area of cybersecurity. Here, what I'm trying to do here is I have 3 sub-modules. I'll try to explain them as they go. But also in some portions, I've also inserted shorter videos, and I tell you, you can watch these videos at your leisure. All right, so this is our normal standard information here on how to reach me. Bio that if you're following the videos, you are aware of this. Copyright information. So in chapter 6, the whole material basically centers around how to deploy network security appliance, secure data via transport encryption, and how to establish and maintain a secure network. So let's get to module A. So module A is the network security component. The objective here is that you should be able to categorize the IDS and IPS systems, which is our intrusion detection and intrusion prevention systems. The ability to use deceptive and disruptive defenses, which we've seen later on about Honeynet, Honeypots, and then choose appropriate application layer security technologies. So for the intrusion detection and prevention, they generally work in a couple of ways. One is the signature database, which involves looking for like known attacks. So it's in a database. It's similar to how malware or antivirus softwares work. Or heuristic analysis, which is you look for abnormal behavior. So to do that, I must have already established what's called a baseline, so I know what is an expected behavior. Because if I don't know what is normal behavior, I will not know what is an abnormal behavior. And then you have what's called the stateful protocol analysis. So this involves looking at the layer 3 PDUs, which are called packets, right, to look for how that protocol is supposed to work. So let's talk about IDS versus IPS. So normal intrusion detection system, we say it's passive. It observes attempts like malicious activity, and then it sends you an alert. But it still requires a human to take an action. Whereas the intrusion prevention system is active, it will actually take an action. Like I see something like an attack, or what I believe to be an attack, I'm going to drop that packet, I'm going to break the connection or lock the account so you cannot access it. So how do we configure this? I can have it on each individual devices, which are the host devices or the end devices, or I can have it in my network as a network appliance. So with the network appliance situation, we will call it NIDS. You can see from this diagram how it is placed. To do IDS, IPS, I need to establish rules. So these rules will say what needs to issue an alert or log the entry. You can make it simple, or you can make it complex. You can write your own rules, but sometimes it is always good to start with a database of existing rules so you don't have to reinvent the wheel. This is a video that I have on IDS, IPS. You can watch it, just show you briefly, and then kind of like a funny video with a mask on here. You can see what I talk about.
Welcome to another.
So this is a shorter video for you to watch later on, all right? All right, so file integrity monitoring to see is the file trustworthy, what has happened with it. So I have a file server, I have the monitor there, I have a signature database, and of course you see on here the SIEM, which is a security incident event management. It's like a way to aggregate your logs on the right side of the screen. But so we have what called deception and disruption technologies. The main one here are honeypot, honeynet, and what is called fake telemetry. So a honeypot basically is designed to be attractive, it says, and accessible to attackers. So I can have like a file on my system that says list of special agents, or list of password, list of account numbers, list of credit card numbers. Right? That could be the honey file. And of course, just the whole idea is, imagine a honey is attractive, right? So something that looks attractive. So you can deploy a whole network of honeypots, that's called a honey net, or individual files on the file server. The fake telemetry is basically a synthetic network traffic that somebody could think, oh, it looks like genuine communication. So maybe if I wanted to tap into your network, I could say, well, that looks interesting, right? So I'm trying to deceive them. So sometimes when you deploy this, is so that you can study what the adversary is trying to do. This is an extra video I have on Honeypot and HoneyNet. It's a little weird video now I'm looking at it, but you can watch it. So it's about 9 minutes. It's part of my micro teach series. Okay, so it tells you.
Welcome to another teaching series. This is still on.
Okay, so watch it. It's on the comment section. We now have something that's called a DNS sinkhole. Remember that the domain name service basically has a website, like if say www.alex.com, and it will match with an IP address, which could be 200.20.20.5 or whatever. So for sinkhole, when somebody it looks for DNS requests from like a malware, and then it responds with deliberately incorrect data. So that way that the traffic is now like directed to somewhere, and maybe to monitor it and see what is happening in there. So this one is based on the domain names, not the IP address. That's how the DNS sinkholes work, right? So there's a discussion, threat detection method, what is best. So you just think about it in your mind. In class, we normally will discuss these issues. So now, if you recall, I told you in the other video that layer 7 of the OSI module is the application layer. So what do we do there? So we have firewalls. If you recall again, we talked about the new or next generation firewalls operating at layer 7 of the OSI module. So the application layer firewalls, they can be very specialized, maybe protect a particular application or service on your network, as opposed to general firewall rules. Remember that I showed the demo in that other video, I think it was chapter 5, where I showed you how you can set up inbound rules, outbound rules on a Windows system. You can do the same thing on Linux. So a web application firewall, for example, is between maybe your network and your web server that has the applications, right? It could be like host-based software or a standalone hardware device. In other words, it's installed on that particular host, right? So it's just telling you that it is specialized against attacks that are targeting web servers instead of just your ordinary firewall, as I just said. We also have what's called a web filtering. If you recall, we talked about allow list and block list, which used to be called white list and black list, right? So web filters, we can use it in like two main ways. If you centralize at the network layer, or obviously installed directly on your endpoint device or your host. So just like say firewalls or IDS, they allow you to block or allow network traffic, right, based on some kind of pre-configured rules. Also, you have what's called a reputational analysis. So the way to filter your network traffic could be one or two ways. Like you have DNS filtering based on like domain name, of course, what's called URL. That's Uniform Resource Locators. I can block individual websites or pages of a website. You just remember that you don't just have www.alex.com, right? You might have .com/ maybe files. Now, let's talk about email security. Many people have seen SMIME, which is based on a digital certificate. You can also have sender policy framework or domain keys identifier. Of course, you have also the DMARC. So here the whole idea is, how do I filter my email to look for what I call nefarious or bad email. So sometimes, now of course now with AI we have a lot of like modules. You train them on what's called supervised learning to detect spam mail, not spam mail. But generally, SMIME it says digital certificates like SMIME or PGP, remember, pretty good protocol on your client level. So this allows signing of messages contents by the person that is sending it, so you know that it's authentic, it has integrity, you can trust it's not been changed, and non-repudiation, meaning that the sender cannot say, I did not send it. You should remember that from our cryptology lessons, right? So those are the other ways you can do email security. Load balancers. This is meant for a network to be more efficient. If you see on the, or at least on my own right side, you see all of these internal servers, and you have a load balancer sitting in the middle, and of course on the left side on my own screen you see external clients going to the internet. So load balancer, just when you request services, it kind of spreads it across, so no one person is doing it. Just like having 3 people carry the load on their head, so you spread it out, right? It gives you more efficiencies, right? But the load balancers can be configured in 2 ways, what's called active or active-passive. So with the active, it just says that all of the redundant servers, like the extra ones, they're always available and they're sharing the load. So if one fails, the load is now distributed to the remaining nodes. If I had 3 and one fails, the other 2 now divide the load. The other way to set up is what's called active-passive. So in the active-passive, so you've got the active nodes, but you have 1 or more nodes that are not active. They are on standby. They call them failover nodes. So if one of the active one fails, then immediately that failover one is activated. All right, so this helps in making sure that you don't just, you're not using all of them at the same time. That one that's idle could kick in when needed. So you heard the word proxy. Proxy servers basically sits between the client and the server. So you as a client, you don't really contact the server directly. You contact the proxy server, and the proxy server now contacts the remote server to give you that information. See how it's set up here? That's a good diagram for the 2, right? So this will be a discussion on application layer security. Just understand that it's more like specialized devices on that layer 7 of the OSI module, or layer, I guess we call it layer 4 of the DoD model. So a few assessment security questions. Look at this here. What device or feature would be the best way to recognize and block scans? So a good network scan tool would be like Nmap or something, right? So you want to see the scans that are trying to get by existing firewall rules. So I probably want an IPS, so that it will now drop or block that traffic, because an IDS is just going to send me an alert. It doesn't really do anything for me. Here, what kind of proxy would you use to mediate communication between internet-based clients and LAN-based clients? Choose the best response. So this is meant to distinguish between forward and reverse proxy. So this answer is reverse proxy, but let me go back to that previous diagram. It wouldn't let me do that, but just remember, go back to that diagram and look at it to see the difference between the forward facing and the reverse proxy. All right. Your department just deployed some fake DNS servers which only interact with automated scripts, never legitimate clients. When they receive unexpected requests, they send an alert to your the SIM. What technique is being used? Choose the best response. So here, let's see. The whole idea is, if you remember, Sinkhole is based on a domain name, right? So this, if somebody's sending you a request, it's not an IPS, right? Because an IPS is not blocking it in here, and it's not the next generation firewall. So you remember, Honeypot is so the fake DNS servers which only interact with automated scripts, never legitimate clients. They get the unexpected request, they send an alert to the SIM, right? What technique is being used, because I want to be able to like study and see what they're doing. You're comparing email servers to see which one is easier to secure. Which of the following security features allows the strongest anti-phishing measures? Choose the best response. This one will be DMARC, but go back and check the notes. Network security complement. So you're considering a web filtering solution that relies on reputation analysis. Okay, what is the that attack. Is it known? Is it a known attack? Which of the following is most likely to be an issue? Choose the best response. So its effectiveness being limited by your threat intelligence program. That's really it. Because your threat intelligence program is going to try and study and feed into your system, right? So if it doesn't recognize a known adversary, known attack, then you might have a problem with that, right? All right, so module 2, secure network protocols. Let's go back again to cryptography. How is it was this placed in the OSI module? How do we choose secure application layer protocols? How do we configure wireless encryption and authentication? And of course, the appropriate VPN technology. It's going to be the first time I think we're seeing VPN in this course. So cryptography, remember I said you have cryptology, you have cryptography and cryptoanalysis, right? Cryptography is taking like something that is plain text and changing it to a ciphertext using an algorithm. Well, of course, we had the other portion about hashing too, right? So it's just telling you here that cryptography, the cryptographic security is not tied to any particular layer of the OSI module, because you can actually apply it to any of the layers to protect your data at that level, or to protect your PDU. So and it says encryption at any of the given layer has the different benefits and drawback concerning what are you protecting and how does it affect your performance of your system. So SSL, and TLS. If I want to secure the upper layer network stack, is the SSL. The newer version is TLS. So they're both certificate-based authentication, and they do what's called a key exchange, right? So most of the time you think about protecting like data in transit, right? It's just saying here the combination of supported algorithm for each category, maybe in the order, so they allow flexibility. And you have what's called a cipher suite that you can use, right? But this is how maybe a SSL or again TLS, which is the newer one. Most of the time, you see it being used in conjunction or in connection with what's called an older protocol, like in case of HTTP, like port 80 communication for websites. We now secure it with HTTPS, which is now for secure website, right? Which will be port 443. Right, so the ways that you can implement SSL or TLS include stuff like OpenSSL, right? As a general purpose, right? You can use it to store and verify your certificate and your digital signature, to generate keys for your public and your secret key cryptography, self-signed certificates, or having a private root or subordinate certificate authority. You can also do this with the hardware. The appliances in here. I've got my workstation to the left, SSL endpoint, packet inspection, the decryptor, another SSL endpoint, all the way down to my internet server, right? So in a minute now we're going to see some port numbers, but you have what's called secure shell. It says it uses TCP port 22. This is part of the public key cryptography. We use it to authenticate connections. But also you can also use it as a tunneling protocol. So tunneling, it's like I want to go somewhere, like in the movies, I want to go from my house to the other side of the town, and I got a tunnel, underground tunnel, right? It's the same kind of concept, but in this case with technology. So I want to go from my house to the other side, and it's not trusted, so I need a tunnel. So in the case of network traffic, right, you have a sort of tunneling protocol. Right? We'll see it in a minute, and I can explain more about how it works, right? So you have also what's called IPsec. This is actually built into IPv6. So it has these different portions of it. You have the internet key exchange that negotiates and authenticates. See here, we have the communication. You have the authentication header, and then you have the encapsulating security payload that encrypts the payload. So if you are taking the Security Plus exam, you might get some general question about IPsec. You will see it in our review slide. Which part of it encrypts the entire payload? Right? Just know that the authentication header says you have cryptographic hashes of the packet contents and then the source identity. So just know that it's divided into different portions, right? But let's see this is the key exchange, right? So again, you see the X.509 certificates. That should ring in your mind. We're talking about digital certificates, right? So key exchange is performed with any or a number of what's called a Diffie-Hellman algorithm. Remember that from last time. And you see AES, Advanced Encryption Standard. This is what is normally recommended for data encryption. You get other older ones, Blowfish, but just understand AES is the recommended one for encrypting data, especially data at rest. So AES, like AES 256 bits. Right? Integrity hashes, we saw this before, MD5, SHA-1, and SHA-3. I mentioned to you that MD5 and SHA-1, they can be used for hashes, but we don't use them in general for encryption because they've been what's called deprecated. Right? So IPsec traffic works in two modes. Just remember this, two modes for IPsec traffic. Okay? Two modes, right? It's like the two modes, tunnel mode and transport mode. So in tunnel mode, it encapsulates and protects the entire IP packet. Okay, but in transport mode, it's cryptographic protection for the packet, then insets them internally. So that could be a good question. The original packet is fully protected by AH and ESP in the tunnel mode, while the outer IP header can use different IP address. Right, so tunnel mode or transport mode. There's a lab. If you're doing this for my students at the university with you certified, there's a lab there, but if you're not taking the class or you have not paid for the lab, just let me know. I can walk you through a lab that you can do. All right, so common network services. Let's just go over this. This could be an exam question. DHCP dynamically assigns your IP address. DNS, we talked about it, relating your domain name to IP address. This is a new one here, network time protocol. This is for synchronizing clocks between network computers and devices, right? Rather than transferring like user data, right? And of course, LDAP, lightweight directory access protocol, is for like a network directory from your domain, right? Directory services across a network, right? Just basically storage. How do you access in the case of Windows at the Active Directory. Remote access protocols. Just know this. We're talking about HTTP and HTTPS, port 80 versus port 446, the differences. We're using SSL and TLS for the HTTPS. For the VNS, it's for like, it's called remote buffer. But RDP, remote desktop protocol, that is Windows, Microsoft proprietary remote access method for you to access to networks. This you will hear about port number 3389. The question is, maybe I need to disable port number 3389, but I get to port numbers again. SSH here is the secure shell for strong authentication and encrypted transmission or communication. Telnet is plain text. Right, so a command line terminal interface for a remote system. You really don't want telnet, right? Because somebody can see what is happening if they intercept. This other 6 here, server message block. Basically, this is for sharing of files or folders over the network. A network file storage is for Unix. You might never encounter that. Unix operating system. I saw that last for me in the 80s when I worked for Florida Resource and Environmental Analysis Center in Tallahassee. FTP is a file transfer protocol. You definitely don't want that. That's port number 2021. We'll see in a minute. TFTP, trivial, or even worse. All right, real-time transfer protocol for streaming of audio and video over networks, and then of course the secure version has the SRTP. So you have the SMB and NFS, popular options for client server, as in one computer giving resources to others, or peer-to-peer for between ourselves. SMB is popular for Windows and NFS in Linux, but you just tell me that you can use it in mixed environment. All right, how do we send email? There's a little error here. I'm going to say I disagree with something in here, but to sending of email, you need SMTP. You see the port numbers in a minute, right? Email servers and clients. You have implicit TLS and start TLS. To receive email, you need a IMAP, now up to IMAP version 4, and then POP3. So these are for receiving, the other one is for sending. All right, so POP3, port number 110. All right, so this is a good slide to remember, especially for exam purposes. If you've taken the Network Plus exam or studied for Network Plus, you'll be able to remember this, right? You just have to remember them. All right, 2021 is for FTP, 23 for Telnet, SSH should be here, 22. The secure versions of each one is there. SMTP, I told you 25. DNS is 53. I already mentioned HTTP and HTTPS, right? 80 and 443. POP3, 110. IMAP, even IMAP version 4, 143. You really have to memorize these ones. So these are called well-known port numbers, which goes from, I believe, 0, it's really no port 0, but just say 1 to 1023. And then you have what I call registered ports for like applications, right? Okay, and then just know the port numbers. When I was studying for the exam, I just printed them, I put on the wall, just go over them all over again, right? So wireless device, this is everywhere now. You go to the Starbucks, which I understand is they are laying off a lot of people and closing stores, but Starbucks or the airport, get Wi-Fi. So cryptographic security and Wi-Fi networks is on layer 2 of the OSI module, which is the data link layer, where you have switches, right? So it says behaves differently than the upper layer encryption like SSL or TLS. The security tends to be handled by the hardware. Sometimes you have firmware. Firmware is what software embedded in the hardware, or drivers in the adapter, and it's not usually handled by the operating system. So this slide doesn't have the worst one, which is WEP. You don't want that. Wireless equivalent protocol. It just talks about Wi-Fi, WPA, WPA2, WPA3. Preferably WPA3 if you have it in your system, right? That just has different encryption standards. We don't talk about, or if you did the networking, you should remember that wireless is operating on 802.11 something, like 11A, 11C, and each one gives you things like 2.4 frequency or 5 gigahertz. Just need to know which one of those. You should have memorized it in the network exam. All right, so what does WPA do? It does like the normal pre-shared key authentication. You see it's easy to Wi-Fi easy connect, and nearly a captive portal like you see at the airport when you use like hotel Wi-Fi. Right, you have to enter some information before you can get on. It warns you, maybe sometimes it gets your phone numbers and stuff, right? All right, so when you're trying to plan for Wi-Fi security, just be aware of these following things in here. Say, preferably, definitely don't use WEP. Yes, your client, whatever the client has is what you're restricted by, but try to use WPA3. Right, configure your client. Encryption, make sure it has encryption, right? And I said don't use WEP. And then when you have WPS, that's when you push the button on your wireless access point or your combined device to access the network. Try and disable that, or make sure you put a pin required for that. So that securing a Wi-Fi hotspot is a good exercise to do. Normally what you do is you remove the SSID, the Wi-Fi name, that's called the broadcast, or you can reduce the signal. Of course, put password on there, change the default username and password. You'll be amazed at how many people don't change their username and password. Most of the time, I could just go on Google and I say, give me the default username and password for, say, Etisalat or Comcast rather, and it's right there. Usually it's admin or whatever. Right. So VPN, virtual private network. You have host to host, site to host, host to site, site to site. So host to host like joins two computers as though they were directly wired together, right? Host to site, a computer to join a trusted network remotely, also known as remote access, right? Like my office site, and of course site to site connecting to trusted network. The two methods, remember tunneling, you got full tunnel. You see here the whole, you see your device on here, you got your computer to the left, local area network traffic all the way there, full. You got split tunnel, see the difference in the diagram in here. You got your internet server, you got your split tunnel all the way to the LAN. So the technologies for VPN could be everything from GRE, PP, PT, layer 2 tunneling protocol, SSL, secure shell. That's some of the technologies used. So in some parts of the world, VPN is supposedly illegal, but if you ever travel like I do, you know that you cannot even access your US web, some banking sites or credit card sites in the US, unless you turn on your VPN to say you are in US, even though you are in Baghdad or something, right? So VPN basically is a very good tool. Also, it helps protect you. If you're using public Wi-Fi like at the airport, please turn on your VPN, right? You can have double VPN or bounce all around the world. Most applications are what called VPN agnostic. You have one or two that will now know you're using VPN. I will tell you this application does not use VPN. Quick assessment in here. This question here. Your wireless access point is currently secured with WPA personal encryption using a shared key. Which of the following is true? Choose the best. It's just telling that enabling 802.1x could increase security, but enabling WPS will reduce it. You don't want WPS. Remember that button on your system, right? So most of them are. This one is almost like self-explanatory in terms of the answers, right? Right. On the IPsec VPN, what protocol negotiates security association? Choose the best one. Remember we talked about the key exchange, IKE. Which secure protocols add SSL or TLS security protocols that were insecure on their own? Select all that apply. So FT, APS. Let me tell you the trick to this question in case you get it on exam. If the S is before, it's not using SSL or TLS, okay? If the S is after, like FTPS, HTTPS, then you know it's using that, right? And of course, for the email, that's the email, Secure Network Management Protocol version 3 uses that. We didn't actually cover that in the slide about that answer, but just I'm telling you now. What VPN type is secure, compatible with nearly any application, and supported by most operating systems? Choose the best answer. That is layer 2 tunneling protocol, IPsec, all right? What security appliance is similar to an on-path attack? Remember, on-path attack is like man in the middle. Alice and Bob are communicating and Alex sits in the middle, right? But it's designed to enhance network security rather than disrupt it. Choose that's your SSL decryptor. All right, our final module here, hardening networks. The whole idea is I'm going to hopefully cover you can learn how to apply network segmentation and isolation, how to harden your network infrastructure. All right, secure network segmentation. Basically, it's chopping up your network into smaller segments. Right? You break the larger network, and this helps for management, but also helps for security. So if I got segment A, segment B, they are all going to be controlled by switches. The only way to communicate between themselves will be like a router. What that means is if an adversary hacks into segment A, they will need to find a way to get to segment B. So it gives me extra layer of protection. All right, so this is one way to harden your network, right, or device. So you basically reduce the attack surface. This will include hardware, software choice. Right? Of course, talk about access control that limits the user's devices and the traffic that can enter your network based on protocol, as I showed you, IP address, even programs. User policies also is good for this. Is how to secure your network. So talking a little more about network segmentation, this is a good review topic from networking. All right, so the smallest network segment is what's called a collision domain. Okay, so this is in legacy networks that are separated by hubs. Like hubs are considered dumb devices, right? So now the fundamental segment unit on modern switched Ethernet network is the broadcast domain. If you remember from networking, let me not say if you remember, I don't know who's taking networking. So when I have IP address, if I send messages to everybody on that segment, that's my broadcast domain, right? So as I say, the most secure way to separate broadcast domain is to place each on its own switch or switches and then physically segment them with routers, right, or firewall. You can logically segment traffic on a switch using VLAN, right? Of course, routers must separate both the physical and logical broadcast domain. Network security zone, I'm going to cover some of this in a minute here, but just understand, but let me talk about that. So I'm dividing up my network and I'm segmenting it for security reasons, but yeah, when I isolate my network, since isolation begins with traffic direction tools like access control list, VLANs, the rules, right? So the whole idea is I want to find a way to restrict traffic between 2 points. So I can do that, like for example in Active Directory, I can use what's called group policies to isolate a server from computers outside this domain. On layer 2, I can maybe configure private VLANs. Of course, in cloud environments, you have what's called a VPC, Virtual Private Cloud. But it's just saying I need to find a way to segment my network. How do I segment it? How do I so network management interfaces. You have two types: in-band management and out-band management. We talked about this previously, a related concept. But here, in-band management just means devices can be accessed through regular network like a web interface, SSH, terminal, or SMP. Whereas the out-of-band management means I'm accessing, say devices can be accessed through a separate interface. It's not connected to your primary network, like a management network interface or a local interface for managing it, right? This is different, something outside. Just see, this is just another concept, jump server, right? For your network. I don't think I can go back, but you just understand segmenting networks. You just need to plan it carefully. Smaller network segments are easier to secure. Each part of a network should be controlled by a single administrative owner. If you need to join systems directly, configure them as you need, right? Member of a network. All right, advanced network structures. Just understand a few of these terms. Deperimeterization, I'm going to cover it one at a time. Software-defined networking or networks. Micro-segmentation, the concept of zero trust, and then secure access service edge, SASE. So, when you hear the word deperimeterization, if you relate it to the word perimeters, right? So how do I, it says integration of cloud service with on-premise systems is one way to deperimeterize my network. If a remote worker is connecting via their home ISP connection or public network wireless line, I'm deperimeterizing my network. Outsourcing, right, is another way. Of course, what the whole is increased use of wireless network, also part of what's called deperimeterization. So this is a new concept, SDN. It talks about the control plane and the data plane. It's for software-defined network. It's basically the control plane makes decision about the overall flow of your network traffic. So you have your southbound traffic or northbound traffic. These are all like controlled. Right, so I'm going to show you. I think I have a diagram in here. But what are the risks of this? Because SDN is about remote management. So that means somebody can attack your network, right? So this is what's called a single point of failure. So if somebody attacks the network management, I have a problem, which means I just make sure I secure my network properly, right? Using a virtual network packet brokers, it says it gives you more visibilities, but you should always deploy this through a securely designed visibility architecture. Now, for the Security Plus exam, I think you should just be aware that it's a single point of failure and it's basically remotely managing my network. If you see any other question that is different from that, that would be surprising. I don't think I've seen review questions dealing with MPBs. So I used to help design questions for different entities. But also what happened is because I used to volunteer for people with disabilities to read exam questions to them. When you're doing that, you cannot teach Security Plus, because you have access to the questions already, right? So we're being very careful. But I've not done that service, I think, in a while, so I think I'm okay here. All right, software-defined one is just another way of having the same SDN, right? It just says this gives you more flexibility. I'm thinking I should have a separate video on SDN, but you can have SDN in your own data center and completely control your network like via software, because that's all we're talking about, software, right? But just that SDN1 is generally controlled by a service provider using some other proprietary protocols that you have to pay for, right? Micro-segmentation. You see how I've segmented networking here using firewall between, on my left, and the internet. I have a firewall. With micro-segmentation, you see how it is? I've got a firewall between, but I now have different firewalls in there, right? And of course, with that, with the one on the right, I have a trusted local area network. But with the micro-segmentation, it's zero trust. Every single device there has to prove themselves, right? Right. So micro-segmentation starts with network segmentation technology like a VLAN. Even the east-west traffic, remember, within a subnet can be controlled. It says telling you some things you need to know. Highly virtualized network topology, centralized network control via the same SDN, granular network traffic. This is implemented by the virtual NIC, because with this kind of virtual LAN or this approach, I have the same network interface card, but it's a virtual network interface card. So zero trust, you heard that once upon a time we had what's called trust but verify. Now everybody talks about zero trust. Everybody must prove themselves. So with zero trust, user login requires additional authentication via an authenticator app or push notification to your mobile device. All the users, they have minimum privileges within the system, unless you expressly granted them privileges, right? There's one called as a newer example of zero trust called remote browser isolation, right? It runs like a browser instance in a cloud-based container. And then you also have zero trust access and zero trust network access. The ZTNA is obviously on network applications. The ZTA is just applying the same concept, but all on identify entities on your network and restricting them with the same doctrine of least privilege. If you recall, or let me just explain, doctrine of least privilege means I only give you the amount of privileges you need to get your work done. So this is an example of a zero trust architecture, right? You got your policies, and then I have the policy engines on top, the control pane. You got the subject, which is the person that is trying to get into my network, policy enforcement point, and then the resource, which means what am I trying to get to, like database. So we've got the control and data plane, right, divided up into two. So that's the components of a ZTA, we just saw in the previous diagram. And then similar here with the secure access service edge. See the ZTNI operates in there. All right, so how do we secure our network data? You need to first identify sensitive data, make sure that it's stored on the network, and if it's designed for external, you need to apply more security, stringent security. Secure our data at rest by ensuring that the host or devices storing it are hardened against attacks, right? Patched, different security measures. If I have issues with other regulatory requirements like PCI, DSS for collecting of credit cards and debit cards, or HIPAA for health records, I need to make sure that I treat those data very seriously, right? How do we secure our network infrastructure? It just gives you a couple of things in here. So, deploy firewalls, IDS, UTM, use redundant security systems when it's appropriate, deploy access control technology such as AAA, which is authentication, authorization, right? Authentication, authorization, and then accounting, okay, AAA, or VPNs or MAC filtering. Utilize strong encryptions. Also keep your appliance firmware up to date and securely configured. Harden your network host appropriately for their network roles. Just make sure that, if possible, use network segmentation to control the traffic between your network and even through your internal network. Same thing, I need to secure my routing and switching because it's easy for adversary to exploit, right? So make sure you configure and secure your time protocol on all your network devices. Secure your switches, which are on layer 2, against layer 2 attacks because they could be subject to VLAN hopping. Secure your routers against layer 3 attacks. Remember, layer 3 with the packets, layer 2 with the frames. It's just saying probably consider subscribing to services against distributed denial of service, which is just something that's provided by your ISP. Right? IPv6, remember IPv4 is 32 bits decimal, whereas IPv6 is 128-bit hexadecimal, 0 to 9, A to F. Just be aware that they have different security requirements. Wireless access points, they are ubiquitous, so you need to secure them. Update the firmware, make sure you have strong encryption, disable WEP and WPS, choose a unique SSID for your network. Don't leave the one that came with the manufacturer. Perform periodic site survey to verify your Wi-Fi coverage and make sure you don't have rogue access points. Sorry, remember, rogue access points are access points that were not supposed to be on your network, as opposed to evil twin that is like similar to the one that you have on your network. Just make sure that you check for those, right? Where do you place your wireless access point? Just put it as close as possible to like the center of where the coverage is required, and maybe but away from outside walls or low security. Don't put it next to the window, or somebody can just grab it or push a button to use it, right? And we'll talk about site survey. Of course, avoid interference with adjacent access points. Use dedicated site survey tools to perform channel analysis and heat mapping to see signal, right? Just like the bad guys go around looking for Wi-Fi signals with what's called wall driving, wall flying, wall walking, right? You should do something similar to secure your network. All right, network security troubleshooting. It says consider the possibility of malicious actions when you encounter connectivity issues. Don't just say, oh, it's just a tech problem. Somebody could be trying to do something to a network. Watch for unauthorized user accounts or rogue devices. Keep all your software updated on your devices. Audit your system. Disable only security measures immediately relevant to your problem at hand. Be sure to enable the security measure after you fix the problem. Monitor for probing or eavesdropping. Some good exercises. Scans your network. A few review questions. What is micro-segmentation primarily intended to control? Right? East-west traffic as opposed to north-south. In ZTA architecture, what is the name of the component that makes access control decisions? Choose the best one. That is your PA. Which security feature is especially important for preventing rogue devices on your network? Rogue devices on your network. Okay, port security. Let me tell you, port security, if you remember, if I know device are going to be plugged into a particular port, I can make sure that only those devices are, by using like MAC address. So if I see somebody that plugs in a device that's not supposed to be there, I can decide what to do about it, like block it or whatever, right? That's a post security, right? Hardening of your networks here. Which Wi-Fi feature should you disable to improve security? Right? Remember the button WPS. All right, so this one, let me explain. Air gap just means systems that are not connected to the internet, right? They stand alone, which is another way of doing segmentation, right? All right, a critical network service is hosted on a legacy server running an obsolete operating system, and you can't replace it until the next fiscal year. So in this case, IPS will be considered a compensatory control, right? What can you place between the server and the rest of the network to protect it? So that is a compensatory control. All right, so I've tried here in 50 minutes. Remember, I apologize, it's going to be long. Hopefully you know how to deploy security components, including IDS, IPS, apply secure transport encryption on multiple layers. I'm using a narration here on this slide so that I can try and change it, just creating a video. So please, as a summary, and then any questions, please feel free to send me the questions. Next will be chapter 7 on this